So I'm going to record this. I had to re-record this, so it might be a little bit rushed and it might be a little bit less uh, fancy than it is usually. As you can see, I'm in my kitchen, so you get to see my beautiful kitchen here. All right, so let's get into it. Basically, all we're going to do is we're going to be multiplying polynomials again, same as last week. And we're going to be talking about something slightly different because it's going to be bigger polynomials. And then also we're going to talk about something called special cases, which is basically just like cool little funky, extra interesting things that can happen when you're doing this, and let you know what it looks like when you get into these little cool special questions. All right, so let's do this first example together. And so I want to just make sure we understand a little bit of the vocabulary. We have a multiplying the following binomial. This is a binomial because there are two parts to it, just like a bicycle has two wheels. And we're multiplying it by a trinomial, that is this, because it has three parts to it, just like a tricycle would have three wheels. And when we're looking at binomials and trinomials, a strategy that we talked about is we want to highlight the different parts, but we want to make sure we're highlighting the sign with the different parts so that they are more distinct, so that we don't make any mistakes with the negatives. So maybe it's pretty clear, but maybe not, that we're going to take the binomial and put it on the side of the box that has two spots, and we're going to take the trinomial and we're going to put it on the side of the box that has three spots. Now, do you have to do it that way? No. There's lots of ways to make a box. There's lots of ways to set up this problem. However, I think this is the best way to do it, so please give it a shot. All right, so now that we have our question set up, we just follow the exact same rules as we would with a normal multiplying of polynomials. So this is 1x to the 1. This has a secret 1 there. I'm just setting myself up for success by remembering the secret numbers. And then remember, we multiply the large numbers together. So we're going to do 5x squared times 1x to the 1 and put the answer in here. Multiply the 5 times the 1 to get 5, and then you add the little numbers. So you're going to do x to the 1 plus, the 1 plus the 2 to get x to the 3. All right, and we're just going to go to the right and keep going the same pattern that we've seen. So 1 times negative 6 is negative 6. 2 x's, so an x to the 1 and x to the 1, that's x squared. Finally, we have 1 times 10, that's 10. There's no x's with this number, and so that means we just say there's only one x. Let's do the second row. 8 times 5 is 40, and then since there's no x's with the 8, you just keep the x's the same. 8 times negative 6 is negative 48. Then, since there's no more x's with the 8, you just keep it a regular 8. And finally, we have positive 8 times positive 10 to get positive 80. And putting the plus signs in front there, you don't have to do that, but it can help you keep yourself from making mistakes if you didn't remember a negative there. Okay, so we are going to now combine our like terms. So this is exactly the same as it was with our previous type of problems, but maybe a little bit more complicated. First thing I want you to realize is this is 5x to the third. There are no other 5x to the thirds, so we just rewrite that. Then I want you to notice that the diagonals are still like terms. So we have the negative 6x squared, positive 40x squared. Since they're both x squared, so we can add them together. 40 plus negative 6 is going to be positive 36x squared. All right. And then this is something kind of new. We have an extra diagonal in this box because it's bigger, but the terms in those diagonal boxes are still like terms, and so we're still going to add them together. So we're still going to get negative 48 plus 10 to get negative 38, and that's negative 38 x's. And then finally, just like on our previous examples, there's a group of ones. There's no other group of ones, so you just rewrite it at the bottom. There you go. You can see it better now. All right. Good luck. Give your on your own problem a shot, the first question in your homework. And when you come back, I'll give you the password. Good luck. All right, I hope you're feeling some success. The password is summative week with an exclamation point, all capitals. So remember, this week is a summative week. That means that everything from last week, week 6, and everything from this week, week 7, is due by Friday at midnight. So make sure you're getting all those things done. Make sure you are turning in your summatives and turning in any missing assignments by that time. That's this Friday, the 19th at midnight. All right, so now we're going to move on to special cases. And we call them special cases. Well, maybe you'll see why we call them special. Reading the question, you'll notice that it says multiply the following using the box method. So we need to use the box method when it tells us to do that. The weird thing about what we see here is that we have a little squared, and there's only one binomial. So remember, a squared, the definition of an exponent is that if it's squared, that means you have 2 of the same number being multiplied. For example, maybe you had 8 squared. That would be 8 times 8, which is 64. So here we have x minus 10 squared, and so that's the same as writing x minus 10 and x minus 10. So whenever you see the squared, it just means you have the same binomial on the top as you do on the side. And so the process is still the same. It's kind of a special case because it might be difficult to understand that what that little squared means, but it's not really that special because once you understand what the squared means, pretty easy to get the right answer because we've been practicing for a while now. So this is x squared, negative 10 plus negative 10, that'd be negative 20. And then finally we have this positive 100, so we just write plus 100. So nothing too special about that. This next one I think is a little more special. And it has one of my favorite things about math in it. We're going to be creating a 0. Ooh, maybe I gave it away. That's okay. So I'm going to put the first binomial on the top, the second binomial on the side, and multiply in. This part is not anything special. But as you'll see in a second, something special, oops, not 80, 81, silly. Something special does happen. Here we have a positive 9 and a negative 9. And if you remember from our elimination unit we just got done with, creating 0 is something that we really, really like in math. A positive and a negative of the same number create a 0 when you add them together. And so we could make a big 0 across the diagonal, combining our like terms. We rewrite the first number, x squared. Then we have nothing to write because poof, we created a 0. It goes goodbye, so long. And then so all we have is the negative 81 left. So it's kind of a unique thing that happens. Nothing too difficult to understand, but just kind of a special thing that happens. So I encourage you to try your best on the next couple questions. Those are your homework questions. Come to the assignment session on Friday at noon. The code is FJ Office 10. If you would, can't see that. FJ Office 10, again, that's every Friday from 12 to 1 p.m. All right, good luck, and as always, feel free to reach out with any questions. Bye.